Now look at the next one. A body freely falling from a height h describes 7h by 16 in the last second of its fall. The height h is. Now last second is dn, which is equal to 7 by 16 of the total distance it has traveled, Sn. So dn for a freely falling body, we can write this as g into n minus half, and this is equal to 7 by 16, and Sn is half g n square. Simplify to get the value of n, and after that get the value of h as half g n square. And the next one, a body released from the top of a tower of height h takes t seconds to reach the ground. The position of the body at t by 4 seconds is. Now t by 4 seconds, how much height does it reach? So let's say h is u square by 2g, and another equation connected with this is t equals to 2u by g. Then you can calculate now after t by 4 seconds, let's h dash be the height. So h dash equals to half into g, sorry, let me come again, h dash equals to u into t by 4 minus half g t square. Now wherever u is present, there you can substitute the value of gt by 2, and that leads to h dash equals to, see, in place of u I am substituting gt by 2, so it becomes gt square by 2 into 4, that is 8, minus of gt square by 2. Now upon simplification, you will be getting that as h dash as 15h by 16. Now moving to the next, the ratio of times taken by freely falling body to cover first meter, second meter, and so on, means first meter, second meter, third meter, and so on, to be calculated. So to cover the first meter, the time taken will be t1 equals to root over 2h by g. So this is 2h. In place of h, put it as 1 meter. So that leads to root over 2 by g. Now in the second case, time taken for second 1 meter, you can calculate that as time taken for 2 meters minus time taken for 1 meter. Now that leads to 2 by g into root 2 minus 1. Now if you look at the options, you can see that the second option coinciding with that, root 2 by g common, and then you will get that ratio as root 1 is to root 2 minus 1. Right? So option 2 will be the right one. Now the next question, a freely falling body travels what percentage of the total distance in 5th second? So distance traveled in the 5th second, d phi by s phi into 100 will be the percentage of it. So if you write that d phi is nothing but it's a freely falling body, g into 5 minus half, I am putting directly as 4.5 by S phi is nothing but half G into 25, and everything multiply with 100. Now, if you simplify that, that leads to 36%. Now look at the next one. If the distance traveled by a freely falling body in the last second of its journey is equal to the distance traveled in the first 2 seconds, the time of descent of the body is. So distance traveled by a freely falling body in the last second, let n be the last second. So we will write this as dn is equals to the distance traveled in the first 2 seconds, half G into 2 square. Now this I can write dn as G into n minus half. This is equal to 2G. Now simplify for this one for value of n, which comes out to be 5 by 2, and that is 2.5 seconds. And the eighth one, a body is thrown up with a velocity of 29.23 meters per second. Distance traveled in the last second of upward motion. Here the velocity has got nothing to do with the problem. The distance traveled in the last second of upward motion is same as the distance traveled in the first second of the downward motion, which is half into 9.8 into 1 square, which is nothing but 4.9 meters. So option 4. Now look at that next one. A body is thrown up with a velocity 40 meters per second. At same time, another body is dropped from a height of 40 meters. Their relative accelerations after 1.3 seconds is. Here both the bodies are under gravity only. Both experiences acceleration G downwards in the same direction. Hence the relative acceleration will be G minus G, which comes out to be 0. Now look at the 10th one. A stone is dropped into a well 20 meter deep. Another stone is thrown downwards with a velocity v 1 second later. If both the stones reach the water surface in well simultaneously, v is equal to. First, let's calculate how much time does it take for a freely falling body to reach the ground, to reach the water. T equals to root over 2 into 20 by 10, which leads to 2 seconds, which means that for the second body which has been thrown downwards, the time taken to travel the same 20 meters will be 1 second. So now let us write for the second body. I am writing 20 equals to Vt v into 1, t is 1 here, plus half into 10 into 1 square. Now if you simplify this one, you will be getting v as 20 minus 5, which leads to 15 meters per second. So which is option 2. Now a body is projected vertically up with u. Its velocity at half of its maximum height is. So at half the maximum height, this is h by 2 position, and at the bottom it has got velocity u, and let us calculate here the velocity v. I mean height, we'll take velocity how much. So let's calculate this as now v square minus u square equals to minus 2g, and here we are writing h by 2. Now let's simplify this. V square equals to u square minus 2g into h can be written as u square by 2g, and this is 1 by 2. Now this gets off and you get u square minus u square by 2, which is u square by 2, and therefore I can write v equals to u by root 2. Option 4. Next, a body projected up reaches a point A in its path at the end of 4th second and reaches the ground after 5 seconds from the start. The height of A above the ground is. Now taking this as the ground, and imagine that the body has been projected up, moving down after Now let's say this is the point A and it has reached this point A after 4 seconds, and after 1 more second, means after 5 seconds from the start it reaches the ground. So total time of flight will be 2u by g, which is given to you as 5, and u value comes out to be 25 meters per second. Once you get the value of u, now this from here to here, this is the last. Here to here, this is the last 1 second. So even here also it will be 1 second. This also will be 1 second. So now height of A is ut, means 25 into t 1 second, minus half into 10 into 1 square. This leads to 25 minus 5, that is 20 meters. Your option 4 for that. 13th one. A ball is dropped freely while another is thrown vertically downwards with an initial velocity u from the same point simultaneously. After t seconds, they are separated by, okay, the first body which has been dropped will travel a distance of s1 equals to half g t square, whereas the second one which has been projected down will travel a distance of ut plus half gt square. Now you are asked to calculate they are separated by what distance. So separated by a distance of s2 minus s1, which leads to ut. Right, option 3. An elevator is going up. The variation in the velocity of the elevator is as given in the graph. What is the height to which the elevator takes the passengers? Now, what is the height to which the elevator takes the passengers? This we have done it in the class where the total height taken or the total displacement is nothing but the area enclosed between the graph and the time axis. So that h can be taken as area of the rectangle plus area of the two triangles. Let us take first area of the rectangle as 3.6 into 8 seconds plus area of the two triangles 2 into half into base into height, which is 3.6. Now upon simplification, This will lead to 36 meters. Next. Right, the displacement time graphs of the two moving particles makes angles of 30 degrees and 45 degrees with x-axis. The ratio of the velocities. Slope of displacement time graph gives velocity. So v1 by v2 will be equal to tan 30. Slope is tan 30 for the first one, and for the second one it will be tan 45, and this will lead to 1 by root 3. So option 4. Now, in the VT graph, the distance traveled by the body in the 5th second. Now look at that. The distance traveled by the body in the last 5th second happens to be the last second. So you need to calculate. Look at the figure now. You can see that that is the area where you need to calculate the figure. You need to calculate the area there. So what will be the area of the triangle? So d phi is area of the triangle half into 1 into 20. So which leads to 10 meters. Next, for the displacement time graph shown in the figure, the ratio of the magnitudes of the speeds during the first 2 seconds and the next 4 seconds. Calculate the slope of displacement time graph that will give you velocity. So first case is v1 equals to 20 by 2. And for the second case, it will be v2 equals to, again, difference in y coordinates is 20, but this time it is 4. Because 2 seconds to 6 seconds, which is 4 seconds. So which means that now first case, speed is coming out to be 10, and in the second case, it is coming out to be 5. Now when you calculate the ratio, you will get v1 by v2 as 2:1. So your option 2 for that. And now the displacement time graph of a moving object is shown in the figure. Which of the velocity time graphs shown in the figure could represent the motion of the same body? Here the body is going up, later on the body is coming down, which means that the velocity should be positive while going up and the velocity should be negative while coming down. Only in option 3 you can see the graph below x-axis showing negative value for the velocity. So option 3 would be the right one for this. Then in the 19th one, a particle starts from rest. Its acceleration versus time is as shown in the figure. The maximum speed of the particle will be the final speed only. Calculate area under AT graph. So that will give you change in velocity. So v minus u equals to AT, which is nothing but area. So calculate the area. U is anyway 0. So v equals to, now area. Area means let's calculate it as half. Base is 11 and into height is 10. This leads to 55 meters per second, which is option 2. Now in the last one, it is the velocity time graph of a body moving in a straight line is shown in the figure. The displacement and distance traveled by the body in 6 seconds are respectively. Here the area, total area above x-axis and below x-axis will give you the distance, and the total area above x-axis minus area below x-axis will give you the displacement. So you calculate the area above x-axis first. That will give you 4 into, I am talking about first this area I am calculating. Look at the figure. In this area I am calculating first. That is A1, let's say, equals to 4 into 2. And I am calculating now the area. Look at the figure again. This is the area I am calculating. Now the calculation for A2, which is below the x-axis, will be 2 into 2. And then A3, which is the area in the figure again. I am pointing, that is the area we are looking at. And that area is again 2 into 2. Now, for the displacement, we have to calculate area above x-axis minus area below x-axis. So this becomes 8, this becomes 4. 12 minus 4, which comes out to be, so this is 12 minus 4, which comes out to be 8 meters. Whereas distance, we will write 12 plus 4. Area above and area below. That comes out to be 16 meters. So your option would be 1 for this.